Hi, guys, and welcome to our first episode of On the Couch with Miss Fersner. As you can see, I'm rocking my Winthrop shirt, but we'll go ahead and jump into things.
So to kickstart our lesson, I need you to get out your ISN. We're going to be on page 11 of your ISN. So go ahead and write the page number at the top, write the date or whatever date it is that you're watching this video, and write the title of our lesson. So we're in Unit 1, Lesson 1. So you're going to write Lesson 1.1, Rational Numbers. We are going to be using Cornell Notes for this lesson. So what you can do is go ahead and draw your straight line all the way down the center of the page. Once you do that, go ahead and write Roman numeral 1, which is going to represent our first section of our notes, rational numbers. Then you can write letter A, which is going to be our first point. Rational numbers are any numbers that can be written as a ratio. When we're talking about ratio, we can represent that with this example using the letter A and the letter B to represent numbers. So a rational number is represented when we have A over B, where B is not equal to 0 and A and B are integers. So essentially what that means is that rational numbers can be represented in fraction format where the denominator is not a 0 and both of the numbers are integers. If you don't know what an integer is yet, we're definitely going to talk about that today. Once you have that written down, go ahead and skip a line and we'll write B for our next point. You also need to know that all rational numbers can be expressed in decimal format. Now, there are two types of decimals that you should be aware of. The first is the terminating decimal. That means that the decimal ends. If we think about the Terminator, Arnold Schwarzenegger, the Terminator ends things. So the terminating decimal is an ending decimal that stops at a certain point. For example, we have 2.5. It doesn't go anywhere further than that. Then we have our repeating decimal. That means that the decimal can continue on and on and on and on. Okay? For example, we have 3.5555, and that 5 can just continue going on. We normally represent the part of a decimal that repeats by drawing a line over the top of that particular number. You can skip another line and we're going to write a Roman numeral 2 for our second big topic of our notes, which is going to talk about the subsets of rational numbers. Now, if you know about the root word sub, then you know that sub means under. So we're basically talking about underneath the umbrella of rational numbers, what do we have? Okay? The first subset of rational numbers is called integers. Okay? So integers include 0, all positive whole numbers, and all negative whole numbers. Okay? I added that little whole numbers there because I forgot to put it right after the positive and right after the negative. But when we're talking about integers, we're talking about all the negative numbers, 0, and all the positive numbers. So we can use this as our example of what integers are. Go ahead and jot that down. The next subset, we can go ahead and write B, will be our whole numbers. So our whole numbers include 0 and all positive whole numbers. So we'll start from 0 and we'll work our way up from 1, 2, 3, 4, and well beyond that. So already we can see there's a difference between integers and whole numbers. Whole numbers do not include negative numbers. Let's skip a line and write C. Our next subset of rational numbers is going to be our natural numbers. So natural numbers include only positive integers, not 0. So it's going to start from 1, 2, 3, 4, and far beyond that. Okay? So notice the difference between natural numbers and whole numbers is that with natural numbers, we're not including 0, just all the positive integers. Now that we have talked about all of our subsets of rational numbers, we can skip a line and go ahead and show you what this looks like in a diagram and work some example problems out. Okay? So first thing we need to know is that when we're representing all of these rational numbers and all the subsets, we can represent them by using a diagram like this, okay? So first we have all rational numbers, and then we get even more specific when we go to the integers, which once again includes 0, all positive whole numbers, and all negative whole numbers. Then we go to just the whole numbers, which includes 0 and all positive whole numbers, and then down to the natural numbers, which only includes positive integers, or what we call counting numbers. 1, 2, 3, 4, 5, and so on and so forth. So now what you need to know is that when we're classifying or trying to figure out whether a number is a rational number and what subset it fits into, we need to know that a number, or remember that a number is a rational number if it can be written as a fraction and a decimal. Now, using this remembrance that we have written up here, we're going to determine what type of numbers these are. What category of rational number do these numbers fall in? Okay, so we're going to start with number 1, 23. First, we're going to ask ourselves, can 23 be written as a fraction? Sure can. We can write 23 as 23 over 1. And that means, or that equals the same thing as the whole number 23. Well, can 23 be written as a decimal? It sure can. 23.0 is the same thing as the whole number 23. So we know that it's a rational number. We know that 23 is a rational number. Now, let's kind of take a step down into each one of these levels and see where 23 would fall. Is it an integer? Well, integers are numbers that include 0, all positive whole numbers, and all negative whole numbers. 23 is a positive whole number, so yes, 23 is an integer. Let's keep going. Is it a whole number? Whole numbers, remember, include 0 and all positive whole numbers. So yes, 23 is a whole number. And then finally, in the natural numbers category, we know that natural numbers are all positive integers, starting from 1 and going all the way up. So 23 is a natural number, okay? So we're going to represent 23 as a natural number. Keep in mind that natural numbers are also whole numbers, integers, and rational numbers because they're right in the center. Let's keep going. Can negative 5 first be represented as a fraction? Yeah, it can. Negative 5 is the same thing as negative 5 over 1. Now, can negative 5 be written as a decimal or represented as a decimal? Sure, it sure can. Negative 5 is the same thing as negative 5.0. Okay? So, it is a rational number. Negative 5 is a rational number. So, let's start there. Okay? It is a rational number. Is negative 5 an integer? We know that integers include 0, positive whole numbers, and negative whole numbers. Negative 5 is a negative whole number, so yes, it's an integer. Is it a whole number? We know that whole numbers include 0 and all positive whole numbers. Well, we hit a roadblock there because negative 5 is definitely not positive. So that means we have to label this as an integer. Okay? Moving along, 6.5 is already a decimal, so we don't need to check and see if it is a decimal. But we can check and see if we can turn this into a fraction. 6.5 is the same thing as 6 and 5/10, which when we write this as a mixed number would be 65 over 10. So it definitely is a rational number, okay? But 6.5 isn't an integer. Remember that integers are all whole positive numbers, whole negative numbers, and 0. A decimal is not a whole number, so we have to recognize this as a rational number. That's as far as it goes. 3 over 5. Can we represent it as a fraction? Well, it's already a fraction. Can we represent it as a decimal? Well, 3 divided by 5, we can't take 5 into 3, so we have to put a decimal point and a 0. Bring our decimal up. That's going to go into 36 times. And so our decimal version is going to be 0.6. So 3 over 5 is a rational number. But is a fraction an integer? Integers are only whole numbers and 0. So 3 over 5 or 3/5 is going to be a rational number. Okay? This concludes our lesson. Go ahead and look in your document and carry on with your practice activities. Happy mathing!